And again, what's the empirical formula? It's the lowest mole-to-mole ratio of whole numbers. So find the moles.
Here's how to do better in general chemistry so that you will appreciate the nature of the science, so that you'll appreciate what the physical universe is about, the fact that there's this thing on the wall called a periodic table that has, 100 and something elements, and the whole universe is made out of just that stuff. And we could imagine raising this concentration by dissolving cadmium metal into the solution. Well, of course, cadmium doesn't dissolve in water, so that's not going to work. We're going to have to be cleverer than that.
General chemistry is often the first laboratory science course a student takes at college. The purpose of this video is to present 9 strategies that will enhance your ability to learn and do well in general chemistry. They are: set goals, manage your time, keep up with the reading assignments, attend every lecture, take effective lecture notes, do practice problems, the importance of ChemLab, use the professor's office hours, and preparing for exams. The first strategy is to write out some specific and realistic goals. Ask and answer these questions on a piece of paper or on your computer. Why am I taking general chemistry? What grade can I realistically achieve? How does it fit into my current academic interests, major or graduate school plans? Tape your goals on your mirror, bulletin board, or computer and regularly review them. Setting some specific and precise goals will help you stay focused.
It's much more self-motivated situation in college. There's not as many strict deadlines, and today we're going to do this chapter and you'll do the homework and I'll bring it into class tomorrow and we'll correct it.
You need to motivate yourself. You need to say, I don't want to be in here just because I kind of think I need to take it, but I want to be in here because I'm going to commit myself to an experience, a learning opportunity that will be unlike anything I may have taken at Dartmouth.
If you do the work and you make an honest effort, you can do well. And it's defining that goal for yourself that I think should be the focus, instead of just saying, oh, it's a weeder class, oh, I'm not pre-med, I won't do good, I just have to take this class.
Chemistry is only going to be one of 3 classes that you're taking, but this is one of those classes where you really need to put in a lot of time to get everything out of it, because there's just so much to cover in such a short term.
General chemistry will make substantial demands on your time.
I think the most important thing that you have to pay attention to in taking general chemistry is just consistency with the work.
Using your course syllabus, create a term schedule to indicate the dates of exams, labs, and other graded work. Then create a weekly schedule to indicate when you have classes and lab. Most importantly, indicate specifically when you are going to do your chemistry each day of the week. Try to do a portion of your chemistry work each day before dinner. You'll learn more chemistry during daylight hours. Plan on spending 2 hours outside of class for each hour in class. Indicate where you will do your chemistry. Use the library, empty classroom, or other quiet place. Do not do it in your residence hall room. Study in a place that will facilitate concentration and learning.
The idea of doing a little bit of something every day, even if it's not, doing all the chapter problems or going through 5 sample tests, but maybe just reading the chapter or at least looking over your notes.
And do problem sets as you go along so that you are giving yourself enough time to absorb the material and really understand its concepts.
Post both of these calendars prominently in your room and study area, and you should also always carry a copy of your weekly schedule with you throughout the day. Review your schedules and make revisions each day before you go to bed or as you eat breakfast in the morning. Keep up with the reading assignments. Do the reading assignment before lecture.
The book is pretty tough to read most of the time, but if you can just look through before class and get a handle on maybe the vocabulary or difficult concepts, just so you have a general idea of what's going on. And then that way, while you're in class, it'll hopefully make more sense.
Because some professors rely very heavily on the textbook and the material on their exams. If they say chapter 12, you should know everything in chapter 12.
Go to every class. Students who do well in general chemistry attend every
We're gonna end
lecture.
chapter 4 today, and we'll start 5 next week. 5, we only do half of the chapter.
What class does for you is give you an outline of the material in a way that's usually a little more bare bones and specific than what's in the book.
Come to class having reviewed the previous lectures or two, and then during the course of the lecture, try to make those notes, ask those questions of yourself as to what was new, what is being developed here, what do I not understand, what am I going to have to worry about. And right here is a glass, so-called frit, a porous piece of glass that allows ions to diffuse back and forth from one side to the other.
You'll become familiar with specialized jargon and nomenclature, not always given in the text. You'll also see lecture demonstrations which explain key concepts.
Sit up front. It makes a difference. You need to stay engaged in the class. And I know from having taken all the intro science classes here that they're large, and it's very easy to walk into the back of that 200-person lecture hall and sit down and half pay attention.
Actively review your previous lecture notes and reading assignments before class.
Note-taking is important. Everyone has their own different style. I would say to stick with the style that you feel most comfortable with.
I use different colors when I take notes. I will, for instance, write all my definitions in blue and draw all my figures in green or something like that. And then that way, when I'm actually taking a test, if I need to remember something, I can see it as that color in my notes.
I would suggest not trying to write down everything the professor says, but try to get down what you need to understand the material. After all, you do have the book, and you can go back and use that as your reference.
Some professors will write everything down on the board, and in that case, write everything the prof writes.
If there's a PowerPoint presentation of some sort or a slideshow being used, it's usually helpful to print that out in advance and have it in front of you. That way you can make drawings on it. You don't have to recopy all of the information, especially when it gets complicated.
And you can always leave a little extra space just in case you don't understand something. You can put a question mark by it and you can go ask the professor afterwards, or you can ask a tutor or someone who's taken the class before.
If you don't understand something in the class, you really want to try to learn it as quick as possible, ideally the same day.
I always have my notes from class right next to me while I'm reading the textbook or rereading the textbook, or while I'm doing problem sets, just because it's a good way to reinforce the ideas.
Review and test yourself on class and textbook notes on a weekly basis. Do practice problems. Try to solve problems in different ways. Use the solutions given in the study guide and student solution manual only to check your answers. Don't look to see how the problem has worked until you've tried to do it on your own.
The general advice is you can't do too many. You also need, when you do them, to ask yourself, how does this fit in? How is this problem related to that one? Is there something else that I could have asked about this particular scenario? So trying to go beyond what just the problem says is a very valuable technique.
I find that problems are pretty much the best way to learn the material, and there's plenty of them in every book, and if for some reason you run out of problems in the book, there's other books available.
Doing the problems is really the only practice you can get for how you're going to be evaluated on the subject matter, and it's the best way for you to sort of evaluate yourself on what you actually understand and what you don't understand.
As you do the problems, make a list of the concepts the problems illustrate. Discuss problems that you can't do or solve correctly with a professor, TA, or tutor.
Use this as a tool, because if you can't answer question 3, then you know you have a concept problem and you should go back and look at that.
The importance of ChemLab.
Chemistry is, at its heart, a laboratory science, so you can do a lot with books and numbers and things like that, but when it comes down to it, the laboratory is where the science is.
Is that what you're doing? All right.
And the lab is, at Dartmouth, it's basically the equivalent of an extra class, and you need to treat it as such. It's not an insignificant part of the course, and since it is graded, you can't let up on it, and you can't just sort of let it slide.
You have to devote a lot of time to the pre-lab questions and then the post-lab write-up at the end. That whole process actually really helps you understand exactly what you're doing in lab, and as a result, all the things that go on in the lab are related to something you're doing in class.
Some students comment that they learn the material better in lab, and I think for them, seeing the practicality of these concepts is eye-opening for them.
The lab's there to physically engage yourself with the experimental act of doing chemistry, just to see that these things that are talked about in the abstract in lectures or maybe demonstrated in class are real, and they're phenomena that you can control in a laboratory environment.
Successful students use office hours throughout the term, not just before the exam.
I think that students don't take advantage of some of these opportunities as much as they could or should, but those who do really are rewarded by it.
You found the moles in point four. We want to extrapolate and see what it is totally. Okay? And so you have these two numbers reversed. I think if you switch it, you'll get a number that's more equal to that.
Okay.
Yeah, I would say this is 0.3. So.
I would recommend going pretty much as soon as you find you're not getting something.
I started by my sophomore year, just introducing myself to the prof at the end of the first class. So they know who I am. So in that 200-person class, when they see my face, they can say, "Hi, Maya." And then I feel more comfortable asking him or her questions, and then they feel more comfortable answering them.
Every chemistry professor I've had at Dartmouth has been amazing. Most of them talk to you on a really comfortable, casual, one-on-one basis.
Preparing for exams.
For me, the best way to prepare for the test was just to do all of the problems, as many as I needed to be solid on that type of question. Usually I'll have a sample test of some sort, or a practice test, or past year's exams.
Which are pretty much a gold mine. I mean, there's no better way to see how you're going to be asked questions, what format, and to put yourself in that test-taking situation.
Pretend you're actually taking the exam. To close the book, close your notes, sit in the room for an hour, work your way through it. And again, because this isn't for real, you can always make little notes to yourself and say, I don't quite get this, I don't quite get that. So I think the preparation for an exam consists of learning what you know and learning what you need yet to learn. While I know some students see general chemistry as a sort of a sieve for students, it's really more of a gateway, an opportunity to get going along the road to more advanced topics in many sciences, not just in chemistry.
Use these strategies to do well in general chemistry. For more information, talk to your professor or contact the Academic Skills Center.